Okay. ठीक. Good afternoon. After the whole day lecture, you may be like somewhat in fatigue mood. So I am not going to take a long lecture. My lecture is not very big. It is very simple, and I will shorten it up. Up till now, whatever you have seen, that all are actually same. All are all confined to a particular theme to increase your to increase the sustainability of your sources. And for this, different methods are applied. And different methods are applied to know how much your source is sustainable. And through water budgeting, we are using different tools. Water budgeting is such type of tool, and you know budgeting, you know all very well what is budgeting. Before going to this topic, I just want to show you some cartoons. This is R.K. Lakshman, common man. It seems that this common man is very happy so far his income is concerned. From his body language, it seems that he is happy because his income is good and his expenditure is less. During that time, probably there is less scope of expenditure, so he is enjoying his life. But after this, after 90s or 2000, source of expenditure is increasing day by day. And for this common man is find it difficult to make a balance between his income and his income and his expenditure, and he tries to maintain the balance. I think he may probably not be able to save anything. So his condition is not very good. You can consider our water budgeting in that sense also. His income source is only salary. Our for in an area where we want to find out make a water budget, there we need to know what is the source of our water. For this, we will go to this. Just it is an analogy between common man in budget and the water budget. So there are some inputs, this is our credit, and there are some outputs, this is our expenses, debits, and the saving accounts is our storage. So what is our income? Income is our salary deposit generally, and expenses is bill, purchasing, petrol bill, all these things are our expenses. Similarly, in this diagram you can see that in the particular area, in this basin, what is our source of income? This is our precipitation. And what is our expenses? This is our evaporation. And there is also a chance of runoff. If you subtract precipitation, evaporation and runoff from the precipitation, and whatever you will get, this is your storage. That means this is our change in storage. That means this much of amount of water is available with us. So now we make this picture slightly bigger to know what is our income. This is hydrologic cycle, you all know very well. And our source of income is precipitation, snowfall, and there is river water also, surface runoff also, and there are expenses, that is outputs, what are our outsource elements going out of the system. This is precipitation, transpiration, and groundwater outflow, surface water outflow. Similarly, someone prepared this for the water for the world. You can see what is the amount of water in ocean, seas, and what is our ice caps, glacier glacier, what is our amount of groundwater, fresh water, saline water, soil moisture, different categories are there. These are our particular point of inputs. So, this much of water is available in our earth in different form. Now, look at the situation for India. This is the water budget of India. See, in India there are 400 million hectare meter of total precipitation took place in volumetric term, and immediately 70 million hectare meter water going out of the system by evaporation. Then the net precipitation of 330 million hectare meter is divided into surface outflows, surface flows and infiltration. And within infiltration there is soil moisture, there is groundwater and surface flow. And how much water is available for us? This is the net groundwater and total surface water flow after subtracting all evaporation and moisture amount, and for surface water, surface flow, flood flow and infiltration to groundwater, that means river water interaction, river aquifer interaction and irrigation outflow. So, only 40 million hectare meter of net groundwater available in our India, and total surface flow is 185 million hectare meter. This is the water budget for India. Similarly, what is the per capita water availability in India? You can see that during 1947, 6,000 almost 6,000 cubic meter of water available per capita. That means the whole common man, common man time. Now the situation has changed drastically, and during 2050 it may comes down to nearly 1,000 cubic meter. Now we will try to find out the component of water budget. So, in this system you can identify the input components. What are the input components? Precipitation, surface water inflow, groundwater inflow. Then for cities, like for some cities, water may imported outside via canals or pipelines. And output elements are evapotranspiration, surface water outflow, the groundwater outflow, consumptive use, these are the things. Then you can remember that we have our water balance equation, input minus output is equal change in storage. Now same situation, same thing we can use what is input component. The input component are these are, and output components we show it that way. That is evapotranspiration, surface water outflow, groundwater outflow, and subtracting from input minus output, this is our delta S. This is the step-by-step procedure to prepare the water budget. I am not going through it, just I will give here because this PPT will be shared with you. First, if you want to prepare water budget for a particular area, so for this you first have to define the area. If it is a city, it may be a block, it may be a circle, it may be a irrigation field, paddy field, so that you want to give irrigation to it, or it may be a subdivision, district, anything may be. And for what time period you want to prepare this water budget? It may be monthly, it may be yearly also. If it is monthly, then you can see the variation of water availability in particular area. And climate. Climate is another important factor, because you want to know what is the rainfall, because rainfall is our prime input element. And outflows and inflows and outflow component. That means what amount of water is going out of the system through river, through groundwater aquifer. But defining groundwater outflow is something different. For this you need a huge amount of subsurface data. There are in morning class you probably heard about transmissivity, permeability, this type of things. We need closed space data of this transmissivity and permeability. So, whatever it may be, we can assume something, but in a way we need to know the outflow component or and surface water outflow component as well as groundwater outflow component. So, in phase 1 you prepare your boundary map, you know your time period, and you list all the inflow and outflow components of your source. Say your inflow components are in a village, say there are 100 dug wells, 10 tube wells, and there are some streams flowing through the village, and in a hilly area maybe there may be some springs also. So, you list out all the elements. These are our input elements, and second you list out another list, prepare another list where you want to know what are our expenditure. That means how much water we are spending for irrigation, for the household use, and for industrial use. You may list out all these things. So, these are your input and outflow component. Then you need to some data collection. You have to find out precipitation. You should know the surface water inflow component, and this can be known by the stream gauges. It may be available with CWC, it may be available with W Water Resource Department. Precipitation data you may know, you may install a small rain gauge station also. And evaporation data, it is difficult to directly, generally it is not estimated directly. You can collect different data such as sunlight, maximum and minimum temperature, wind direction. All these data can be used, taken, and it can be put in a formula, Penman Monteith formula, and you can do it in, there is a software, crop water software by Food and Agriculture Organization. It is a free software. There is another software, climate software. With this you can get able to calculate evapotranspiration for a particular area. So, groundwater data, groundwater inflow and output component, you need some aquifer properties like hydraulic conductivity, transmissivity, water level data. These are data is available with Central Groundwater Department, that means with us, and it is all now groundwater data is publicly available also. Then return flow, if you give irrigation water to your paddy field, then some of part of the irrigated water is infiltrated to the aquifer. This is another component of research. So, these are the outflow components you need to know. Now, you have to calculate the storage. The simple formula is given. Main part is calculation is not a problem, but main problem is your data collection, because data is generally not available, and generally in our state departments and data is not properly maintained. But nowadays data is the main factor. Now, if you calculate the delta S, then you can measure the change in storage for groundwater. You can measure the water level. In Central Groundwater Board measured water level 4 times in a year. One is in pre-monsoon time, that is in March. This is the deepest water level. Another in before March, there is another water level in measurement during January, and one is in August, that means in monsoon season, and another in post-monsoon season. So, change in storage, you can, if you see that pre-monsoon water level is generally deepest and post-monsoon is shallow. So, difference between pre and post-monsoon give you the storage. This much of storage, say in pre-monsoon time water level is in 10 meter below ground level, and during pre-monsoon time it comes to 5 meter below ground level. So, change in storage is 5 meter. If your area is say 10 hectare, then if you multiply 10 hectare with 5 meter, then you will know the volume of the your storage. That means 50 hectare meter. This is the direct measurement to know the change in storage. If you, or if there is some tanks or ponds in your area, then you can also measure the water level of the pond and area, and it is a direct measurement. And you can also calculate it with your water balance equation. And you can compare these two results. If these results are matching or nearly matching, generally it will not match completely. If it is too high, then you have to recalculate your calculation. Anyway, this is some about your change in storage calculation. But what it is implies? Change in storage, that means delta S. What delta S means? If delta S is negative, what you will able to know? Delta S is negative, that means your precipitation, your input component is less than your output component. That means you are expending more water than your than the water coming out into your system. So, this is negative situation, negative. Or if delta S is roughly or 0 or positive, it is a good situation, because your credit and expenditure are in a balanced situation. So, this is a sustainable way to grow, or if it is positive, this is well. If it is negative, then your area is in a condition of it is a vulnerable condition, it is at risk. So, you need to take some measures. What are the measures? You can go for artificial research for groundwater, you can go for some plantation, you can change your cropping pattern, because some crops are water intensive, say paddy, sugarcane, these are water intensive crop. So, if you reduce the amount of water irrigation, irrigated to the field, then maybe your resource may come up. So, these are the various measures you can take up. So, this is a tool by which you are able to know the sustainability of an area. So, for sustainable groundwater sources management, water budgeting is important. So, this is the why this is important: planning for droughts, impact assessment, pollution control. Moreover, the water budget situation, you can modify it as per your demand, because say in your area is affected by arsenic or fluoride contamination, some sources are affected by arsenic and fluoride contamination. So, say your area has 10 wells, out of 10 wells, 5 wells you have seen that there is an arsenic contamination. So, you are not going to use that arsenic affected wells. So, that means your input components are somewhat reduced. Again, maybe there is a river in your stream nearby your area, but this stream is polluted by urban dumping, say people are using it as dumping ground, or somewhat it is polluted. Then you are not going to use your river, that stream, as your source of water, because it is not helping you anyway. So, this is another way that you can modify your water budget equation. So, this is a these are all about your water budgeting. Thank you. Anything? Yes. If it is clay, your top soil is clay, and say it is lowermost area zone is also clay, then you can go for some research shaft. You can construct some research shaft. That means you have to cross that area, a clay zone area, by constructing a shaft, and you put water and you put filter material within this research shaft, and you put water. You can artificially recharge the aquifer. Ah, yeah, yes, because it is a clay, that is why you have to cross that zone. No, yeah, actually it is coming out from measurement from in different times, because in actually in another part of the India, post monsoon season starts in May, June. But in May, June, in our area, there is continuous rainfall and the water level is coming up. This is proved by our measurement also. But during March, it is seen that it is the deepest water level at that time. It is before the month onset of the, in April also we have some rainfall. So March is generally dry period, dry time. That is why it is March for pre-monsoon water level measurement. So I think there is no question. Okay, thank you.
আমার শেয়ার করে দিন আমি গ্রুপত শেয়ার করে দিন